Hello everyone, welcome back to AlgoWorld. Today, I thought that we would try our first algorithm instead of another data structure. And I was thinking, well, what better way to start than with the good old-fashioned Euclidean algorithm, which is most typically the first algorithm you're going to learn when you take your discrete mathematics course. Now, the statement of the Euclidean algorithm is it's pretty simple. A equals bx plus r, where a and b are the numbers that you input to find the greatest common denominator between the two. X is the largest multiple of b such that b times x does not exceed a, and r is the remainder between the two numbers. You can have a negative remainder if b is the larger number to begin with, or if you input something for x that is going to result in a number that is bigger than a. But we're not going to do that today because that adds unnecessary complexity. So if we start with the inputs 10 and 4, then we see that, well, 4 times 2 is 8, and 10 minus 8 is 2, so the remainder is 2. We then shift everything. We shift a to the value of b, which is 4, and we shift our value of b to the remainder value 2, and repeat this process. In this case, we get 2 times 2 is 4 with a remainder of 0. If this number becomes 0 or 1, the algorithm stops, it terminates. And this value for b right here is the greatest common denominator between these two numbers. Therefore, in this case, the GCD is 2. Now, creating this in code is it's also fairly straightforward. We come in with our GCD function. We name a number 1 and a number 2, and I'll ask that you keep the toilet jokes to yourself, as much as I would love to entertain them right now. We initialize a variable called remainder. We initialize it at 1. We don't initialize it at 0 for a reason that will become very apparent in just a moment when we create this while loop. And we ask it to keep track of this value for this remainder. Now, what we're going to do is set remainder equal to the number 1 modulus the number 2. Modulus just gets the remainder created when you take the number 1 and divide it by number 2. Alright, now we'll shift things. We'll set number 1 to the value of number 2, and we'll set number 2 to the value of our remainder. And that's all we need to do inside of our loop. Now on the outside, once this loop terminates, we're going to check the number 1 and see if it is equal to 1. If it is, then we'll set the result equal to the string. This is well, these. Learn that grammar, folks. These are coprimes. And if not, we'll set the result to these are not coprimes. And we'll go ahead and return that value. Now, we'll go ahead and call the function with console.log. And what numbers can we pick? Let's do 786 and 54. Yeah, those seem like good numbers to start with. All right, as we can see, these are not coprimes, and you can probably tell that immediately because both of these are even, so they at least have a GCD of 2. Let's try another one. Let's do a GCD of 5 and 4. Now, I think you should know the answer to this before I even click enter. It's that these are coprimes. The largest number they have in common is 1. That about does it for the Euclidean algorithm. I hope you've learned something today, and I hope you'll consider joining me again in the future. Have a nice day.